2D arrays are what they sound like. They're two-dimensional arrays. And you can basically use 2D arrays to create what we would normally think of as a spreadsheet. So we'd have rows and columns in our array. So this would be, and remember the numbering still starts at 0. So these are our columns. We have 0, 1, 2, 3. So this array has 4 columns, but it starts at 0. So we still have, the first element starts at 0. The last element is still n minus 1. And then this one has 0, 1, 2. So it has 3 rows. Numbering starts at 0. So the way that we would define this array is, first of all, we need some constant integers to define the number of rows and columns. And with these, it's usually a good idea just to stick to the names rows and columns because it'll be less confusing that way. But so let's say rows is 4. Actually, yeah, no, rows is 3. So this one has 3 rows. And columns is 4. So then the way we declare our array is, let's say this is an array of integers. And we can do two-dimensional arrays using any data type, sort of like the arrays, sort of like the one-dimensional arrays. So we could have an array of doubles, array of strings, array of characters. This time we're going to have an array of integers. Let's say this is exams, so maybe this is exam scores. And we're just going to have rows, columns. So rows comes first, then columns. And so this is how you declare a 2D array. And we can access this array by putting in the indices of the row and column. So for instance, let's say we want to access this spot. Let's say we have 90 stored there. So, well, actually, let's say we want to store 90 to the first row and column. We could just say something like exams 0, 0 equals 90. So that's going to store 90 to 0, 0. Since row comes first, this right here is 0, 1. So it's row 0, column 1. Right here, this is row 0, column 2. And, or if we go down here, this is second row, so row 1, because remember it starts at 0. And then this is column 0. So whenever I'm working with 2D arrays, I usually write out this actual diagram because it's a lot easier to visualize what's going on if you draw the diagram. So we can do basically everything we were doing with the one-dimensional array with the two-dimensional array. So we could do, like, we can see out what we have stored in the array. So see out, let's say exams, and then let's do, so this is the third row, so it's going to be 2, and then this is column 0, so this would be 2, 0. So if we do a cout statement and we access that element, it's going to display whatever we have stored in that element. We can also initialize 2D arrays. So let's say that we have, let's do a simpler array. Let's say that we have an array that has 2 rows and 2 columns, and let's say we have 84, 78, 92, 97. So 2D arrays are initialized row by row. So we start with row 1, go to row 2. So what I mean by that is this array is going to have, so we still want to call, so we still have our rows, our 2 columns, our 2, and then we can declare and initialize this array by saying int exams rows columns is equal to, and then we do some curly brackets, and we're going to start with row 1 and put what we have in row 1. So we have 84, 78, curly bracket, another curly bracket. This is going to be the second row, and we have 92, 97, and then we have some curly brackets. So this is row 1. this is row 2, and you just keep going. So you just put all of your rows in the curly brackets in this format. One thing I want to mention is you don't actually need these inner curly brackets. You could just list everything out row by row. But I think the inner curly brackets are a really good idea because it's a little more obvious what you're doing. If you just do it like this, 84, 78, 92, 97, that's a little more confusing what you're doing. It almost looks like you're just doing a one-dimensional array. But I just want to point out you don't actually need those inner braces, so you might sometimes see programs that have 2D arrays and they don't include the inner braces. I recommend using them, but just so you're aware. And we can pass 2D arrays to functions. So passing 2D arrays to functions. So the way we do it is, let's say this is our function header. So void, and let's just do the show array again, only let's say this is a two-dimensional array. So we have, and since we're just displaying what's in this array, we probably want to use a constant. And actually that code we just wrote where we were passing the arrays that we were just displaying or just comparing, we probably would have wanted to declare those as constants so they couldn't be changed. So constant int numbers, and then we need to send it the number of columns, and also it's going to be int rows. So this is going to be our function header. So when we're passing a two-dimensional array, we have to send it a parameter type that contains the number of columns. So basically, this function could take any two-dimensional array that has the number of columns we've specified. So if we specify that this is 3, we could send it any two-dimensional array with pretty much any number of rows, but it has to have 3 columns. And the reason why it could pretty much have any number of rows is because we can send it the rows as a parameter. When you're using two-dimensional arrays, I recommend calling your number of rows and number of columns, rows and columns. Otherwise, it gets kind of confusing. Function is just going to show the array, and we're going to send a constant so the function can't change the array, because remember, when you pass an array to a function, it acts kind of like a reference variable, and the function has access to the actual array in the calling function. So if you don't want the function to change your array, it's a good idea to use this constant. That makes it so the function can't change the array. And then for a two-dimensional array, we still have the brackets, but then we have a second set of brackets with the number of columns. And then we send the number of rows. So this particular function, we can send any two-dimensional array into this function with the number of columns specified. So for instance, if the columns, because this is a constant here, so if it has 3 columns, then we can send any two-dimensional array with the number of rows specified and that number of columns. If we call our function, the way this is going to look is like if we call this function inside, say, the main function, we have show array, and then let's say that the name of our two-dimensional array is just, what did we call it up here? Exams. So we're going to send it exams, and then the number of rows. So this is going to be, let's just say, rows. So this would be our function call. So this is how you would call the function. And so this is why in your prototype and your function definition, you have to specify the number of columns, because you don't actually send it the number of columns. Besides a two-dimensional array, we can also have arrays that are 3 or more dimensions. And this gets kind of interesting. We can, in C++, we can define arrays with any number of dimensions. So for instance, let's say we want a 3-dimensional array. Let's just say it's an integer data type, and I'm just going to call it rect solid. And let's say it has 2 rows, 3 columns, and then a 5th dimension. So the way that I like to think of this is like spreadsheets. So in Excel you have pages, right? So you might have like multiple pages, and each page is 2 dimensions. So that's kind of how I think of this. This would be your rows, columns, and then this would be your pages. So 3-dimensional arrays can be pretty useful. We can do even more dimensions. We could do something like double. Say that again.
So it's like folders.
Yeah.
Oh.
Yeah, I guess you could consider it like that.
It's the same amount of different other folders.
Yep. Yeah. So let's call this like time grid, and then let's say this one's 4 dimensions. So 3, 4, 3, 4. So you can have an array that's pretty much any number of dimensions that you want. And if you send this array into a function, the prototype needs to know everything but the first dimension. So when we use this as a parameter, we have to specify all but the first dimension. So for instance, if we were using this rect solid 3-dimensional array as a function parameter, our function prototype would look like this. So let's say it's void rect solid, and then this is an integer data type. We just have the first brackets for the first dimension, and then we have to specify what the other 2 dimensions are. And then we have int for the size, and that size is going to be the number of rows. So I've used 2 and 3-dimensional arrays a lot. If you're reading in data from spreadsheets, 2 and 3-dimensional arrays can be pretty useful. Finishes up chapter 7. So we're not going to get into vectors. You're going to cover vectors in the 1410 class. So we decided to just focus on arrays in here and wait for vectors in the next class.